Perfect. There we go. Okay. All right, here we go. So let's do the first spin. I think I got everybody in there. And we'll see who our first winner is. Mariana Schlesk. That's a lot of H's. Schleska. I'm sorry I butchered your name, but Mariana, we'll go ahead and reach out to me. Shoot me a message on here, and we will make sure to get you your $50 gift card. Awesome! Congratulations. We will remove you for the next one.
Terrific! Way to go, Mariana. Now, remember, we're going to have another spin of the wheel. You're welcome. Joshua says congrats as well. We're going to have another spin of the wheel, but it's towards the end. So making sure that you are there for that as well. And now our next one is Robert himself presenting on total eclipse of the chart to show his school redistricting dashboards and one of his favorite quotes from Robert Louis Stevens.
Thanks, David. Appreciate it, and thank you all for attending to our Tableau user group today. So this presentation is on, like he said, on school redistricting dashboards with its punny name of total eclipse of the chart. They like that at the Tableau conference. When I applied, I knew that would always help go a long way. I was fortunate enough to have the opportunity to present at the Tableau conference this year back in April. Of course, we went through introductions earlier. I'm Robert Kramer. I'm still the Data Systems EMIS Coordinator in Southwestern and Grove City, Ohio. So let's go ahead and go on to this here in our agenda. So first, we're going to talk about how Tableau got its start at Southwestern City Schools, bit of background. We'll go over some of the groundwork that had to be laid in the years prior to undertaking redistricting in Tableau. Next, we'll talk about the specific project that led to the creation of these dashboards. Then we'll cover the enhancements that we made to this first project, and finally, we'll bring it all together with SQL. So yeah, we do always like good quotes at the beginning of presentations in the K12 TUG here, and as David showed on the intro slide, I've always liked this one from Robert Louis Stevenson, the author of Treasure Island. Yeah, I'm told there are people who do not care for maps, and I find that hard to believe, and I couldn't agree more. I also find that very hard to believe. We all know it's the most fun part of Tableau and a fun part of life, frankly. Okay, so let's talk about our school district's journey into Tableau. We're one of the larger school districts here at Southwestern, both physically and in terms of student population. Our district covers 119 square miles over much of the southwestern quadrant of Franklin County. We're based out of Grove City, but we cover numerous municipalities and townships, including a sizable portion of the southwestern part of Columbus. We have approximately 22,000 students, pre-K to 12, across 34 buildings. We have 16 elementaries, 5 intermediates, 5 middles, 4 highs. We have our own career academy, an alternative school, a couple preschools, and a Head Start. So we have a definite need for handling large amounts of data. Our student information system is Infinite Campus. We're now finishing our 13th school year on Infinite Campus. We've been very happy with everything that Infinite Campus has delivered to date. They've always shown to have a very good appreciation for data and ensuring our access to it too. So we've also been handling data in Crystal Reports since 2005, far predating Infinite Campus here. We still use it today because of your goals of form like layout or spreadsheet. Crystal Reports is a good option. It's a good supplement. Then in 2016, Tableau came along here, and it has slowly but just dramatically changed how we do business here at Southwestern. In 2015, Curriculum approached us about a data warehouse. They wanted to get a better handle on student data and understand it better. They didn't know exactly what they wanted, or even they didn't even know what a data warehouse was. So of course they didn't know what we want, so we didn't know what we were looking for. But we sat through a lot of presentations, some decent enough, some not so much. But we finally heard about Tableau and how Custom Computer Specialists, a partner of Infinite Campus, had developed their DataViz API product to integrate Tableau to Infinite Campus. It was actually just a small article in the Infinite Campus Yearly Magazine that we had noticed. The integration between Tableau and Infinite Campus, it's two-way. So there's data communication going in both directions. And so it's so well integrated that users wouldn't even know they're using a separate product if we didn't want them to. But of course we do. We love Tableau. We want to brag on it. Dashboards are displayed within the Infinite Campus browser window. There's no separate login. And access to each dashboard is actually controlled through Infinite Campus permissions, just like any other tool, right, of IC with user groups or individual users. The employee groups that currently have access to Tableau at Southwestern are the district office, school front offices, math and literacy coaches. There hasn't been a big use for it yet to get it in the hands of individual teachers, since they don't typically dig into big data as much. They're usually more looking at individual students. Year and school rights must be inherited through access in Infinite Campus. So a school level dashboard will only run for you if you have access to that school. A district level dashboard is only granted to specific users, typically our district office, central office. The speed is just amazing since it utilizes Infinite Campus's own data warehouse product, though it doesn't have to. I mean, we can pull from anywhere else, including the live database or other databases. Our data warehouse is automatically updated with the latest data nightly. So all data is no more than 1 day old when we're using that. And most of our dashboards use the data warehouse. And as with many data warehouses, our ETL process, for our ETL process, we create views to be flattened into tables overnight, which can really allow us to have huge amounts of data that can be accessed at great speeds within Tableau. Or we can even let other products access that data warehouse if we need to, or export from it. Custom even provided several dozen canned dashboards to get us started in learning Tableau through modifying and reverse engineering some of these dashboards. Very helpful to get us going. We definitely did have our share of challenges when we initially started ramping up with Tableau. When we first adopted Tableau, we only had 2 employees available for development. And to be honest, our plates were already pretty full. So it was difficult not just to find the time to develop dashboards, but to even learn how to develop them. We got some training, but it takes time to get good at this, right? So how do you solve that? Like many times, sometimes it's better to be lucky than good. We had another employee within the department retire, snagged a great new hire, freeing up more of my time to focus on dashboard development. But another issue that we faced was expectations. In addition to the initial problem of time, we had to make sure administration understood what Tableau was and what it wasn't. Some were immediately speaking of Tableau essentially being magic. And while it is really amazing, we had to explain to them that it does what it does because we've told it to. It's still a tool, just like anything else, just admittedly a super cool one. Some people wanted to see a single dashboard to be the be all end all where all data possible could be accessed if drilled down enough. So we had to bring them back a little bit, explaining how, while we can certainly bring data together, some data together into a single dashboard from different parts of the database, different types of data, there will be different dashboards to tackle different questions. So we had to dodge scope creep several times in the beginning. We would have to tease out the details of what people were looking for sometimes. They might say, I want a behavior dashboard. Well, that's great. What would you like on this dashboard? What type of data would you like to look at? And most importantly, what is the question you're trying to answer? That's, I think, one of the most important lessons I took from my boss week 1 when I started here. Find out why they want something, whether it be Tableau or anything, really, any project. On top of that, with limited human resources, prioritization was an issue because development was, of course, slow in the beginning. So which projects should get priority? Because everyone's opinion is theirs, right? Ultimately, this culminated in the establishment of monthly Tableau update meetings. Here, our team could discuss with the deputy superintendent, curriculum, and the assessment coordinator on our accomplishments for the past month, new requests or enhancements and their prioritization, and the logistics of future rollouts. Those meetings have proven invaluable to keep everyone on the same page. And over 9 years later, we still hold those meetings monthly to this day. So if you're not already holding such a meeting, I highly recommend your district think about doing so. Here's a Tableau. Here's Tableau in Infinite Campus, a simple Ohio school district map dashboard. Like so many products these days, Infinite Campus is browser-based. On the left is Infinite Campus's indexed navigation. It's within that navigation that we access our Tableau dashboards. It's a hierarchical structure, so sorting the dashboards into what are essentially folders makes finding the dashboards you want easier. So before we start into our big redistricting project, I wanted to show you the groundwork that needed to be laid for us to get to this point. This includes predecessor dashboards and ensuring that all the data we needed to come up with this solution is in place and accurate. So first, we need to talk about how addresses and school boundaries are handled in our student information system. When we started with Infinite Campus in 2012, we worked with the Mid-Ohio Regional Planning Commission, or MORPC, to help ensure that every address within our school district boundaries, Franklin County, and within a 10-mile radius of Franklin County was loaded into Infinite Campus. Every address in Infinite Campus is its own independent data point, its own row in the address table. Um, in addition to the typical postal address that you see here, Infinite Campus supports latitude and longitude, which is, of course, essential for mapping points in Tableau. We also created custom elements and addresses, including municipality, township, apartment complex, mobile home park, and even parcel ID, which, if you've ever worked with that data, you know that gives you the keys to the kingdom with county auditor data. Now you can cross-reference that with just about anything. On the right is then our school boundaries in Infinite Campus. Our district has 4 school levels: elementary, intermediate, middle, and high school. Campus not only supports these 4 levels, but also a history of former school boundaries for a given address. So each school boundary is also one row in the school boundary table in the database. You can see there we have old ones, one old one, and then one new one. We did elementary redistricting a little while ago, about 10 years. So with all of our addresses geocoded, it allows us to plot maps in Tableau like this one. Here is every single address in Southwestern City Schools, about close to 70,000 now, I believe, whether or not any students actually live there. You may see the word catchment on here. So what is a catchment? It's a unique combination of schools: one elementary, one intermediate, one middle, one high school, that a student at a given address would naturally attend. Obviously, there's other reasons for kids to go to different schools, like special ed programs, etc. That's where they will naturally attend, and most will. We currently have 37 unique catchments, each one represented by a distinct color on this dashboard. Here's one where we utilized a shapefile from the state of all school districts, over 600 of them in Ohio. The state requires us to report all admissions and withdrawals of our students, as most states probably do, along with the school district they're coming from or going to. And this heat map shows how many net students that we gained or lost from a given district. Just a quick example of an earlier dashboard where we took advantage of a shapefile from the state. This was my first attempt at just kind of an early proof of concept in having both address points as well as shapefile geometries displayed on the same dashboard. It wasn't particularly useful or pretty, in my opinion, but it allowed me to show to administrations just some ideas for what we could potentially build in the future. I think it went a long way with that, helping to convince them that what we could potentially do. And lo and behold, a few years later, just such a project came along. In the fall of 2018, voters here approved a bond with the help of state funding to rebuild 4 out of our 5 aging middle schools and provide renovation and expansion of our 5th middle school. So if the schools are being rebuilt one by one, why the need to redistrict? Well, 2 of the middle schools were moving for various logistical reasons, and one of the middle schools was an old high school. So while 4 of the middle schools were increasing capacity, Pleasant View Middle School, the one that was formerly the high school, was actually it was decades ago, it was a high school, by the way, was actually decreasing in capacity by over 150 students. So the charge from administration was to redistrict 130 students from Pleasant View Middle School to Brook Park Middle School and 60 students from Pleasant View to Norton Middle School, in addition to making the 2 school moves make sense. You put this all together and you end up with a definite need to redistrict. So what you see here, these are exactly the charts that we were trying to eclipse, and there's where the punny session name came from. These charts are from a previous redistricting project with our elementary schools I referenced back in the early 2010s. The way this worked is that we would send over a bunch of student grade and address data to a GIS house that we contracted with. We'd give them the guidelines for what we were looking for. Then they would usually give us 2 to 3 options on how to redistrict with all of these charts. And there were many more. Oh my gosh, there were so many when I was digging out the old paper, which we shockingly still had. Don't get me wrong. I mean, these were great to work with and gave us some good options. But if we had any feedback, and of course we're going to, then each time we would communicate, we had to just kind of lob it over the fence and wait a few weeks while they reworked the process. It created a lag. It would extend the process, and we wouldn't quite get as detail oriented we would have liked. If we could do this in-house, then we could pull together all the stakeholders in a meeting, go over drafts, and then live on the spot tell them what the impact of a change would be, not just for next school year, but even subsequent school years beyond that. And this was the dream. It was what my director and I were able to convince administration to give us the opportunity to pull off, turning Tableau into even more than dashboards, but a functional tool. So this is the Tableau dashboard that we developed. But how do you test and analyze different redistricting options? This was, for me at least, the crux of the project and was the hardest issue to work through. Current boundaries are easy. They're stored in the database. Redistricted boundaries are not. How do you allow for easy movement from one hypothetical boundary to another? And the answer, it turns out, is sets. We tried many different ideas, but this is the only one that gave us that needed flexibility. We just had to initially set up the 5 sets to be the same as the current catchments. Then we could change them and test them. The reason for 2 maps was it was actually due to a limitation at the time in Tableau where you couldn't update a set's members on a worksheet that itself was affected by the changes to the set membership. That's no longer a limitation now, but it was then. So 2 maps. The map on the left represents all district addresses and our now former middle school boundaries. So this is our workspace. Current and new school locations are represented by the letters on the map. You can see N for New Pleasant View, N for New Brook Park, and there's Brook Park and Pleasant View, and the others. The map on the right represents the resulting map from our redistricting efforts. So this is our results map. This map looks thinner because at the moment it only shows addresses with current K-8 students. Those are options how we can kind of do this. We found that to be the most useful way to kind of see what the real impact is. This gives us 2 very different but equally important perspectives of our district map and our population distribution. To redistrict a neighborhood on the left map, you can highlight a neighborhood, select to remove it from one set, a middle school boundary. Once removed, then select to add it to the other set, a different middle school boundary, and that's it. You've just created a new scenario that you can analyze. To examine the scenario more closely, you can then look at how it would affect this year's student numbers with the bar graphs in the middle of the screen. Each school has 2 graphs, one representing the 7th and 8th grade student numbers for the current boundary and one for the redistricted boundary. The gray reference lines represent building capacities. Both old and new capacities are accounted for in their respective bar graphs. Right here. The heat map style at the bottom shows overall numbers redistricted. You can hover over any one of these address points for more details and over any of the graphs for more detailed viz and tooltips. In all, there are 15 worksheets comprising this dashboard, including the viz and tooltips. All right. So how long does this process take to do? It's less than a minute. Here we can see we're highlighting right here this neighborhood, and we're going to go there and remove them from the Norton Middle School set, the orange. And if you watch here on the right side, these are going to change from orange to gray in about 10 seconds. And we're going to, indicating that it's undistricted. There we go. They're undistricted. Now we're going to do the same thing. We're going to highlight that same neighborhood and now add it to Pleasant View Middle School. And then approximately 10 seconds later, we're going to see it change from gray. Remember, it was orange before, and now it's green. And it's been moved. Okay. So one of the important things about this process is for us not to be short-sighted. When we redistrict for the current year, we need to be sure that this is sustainable as the lower grades matriculate into the middle schools. So as we tour through that, this is how we would do that. So first of all, we're going to go up to Brook Park, and there you can see the capacity right there is 622 in the old Brook Park building. There are the lower grade levels and how many students were in the current and then in the redistricted. Jackson, there's the current. That was one that had very little redistricting, just a couple kids, kind of a side quest. Norton Middle School, there's the current, there's the redistrict. So you can see we don't have any big things happening. Pleasant View, the old was going down a little bit. And the new, it's fewer kids coming up from kindergarten. So that's something we'll have to be aware of as they move up through. And here at the bottom, like this right here would be all the kids who are specifically currently in PV and are being redistricted to Brook Park, the 130 some students. You can see that there's more now than what will be later. So it kind of levels off a bit, and we'll even reference that later, how that's kind of okay then to redistrict a few extra. It wouldn't hurt anything. Here we go. So this was the original map. You can see where the 5 current middle schools are denoted by the single letters, just like on the dashboard we saw, the other dashboard, while the new ones have an N in front of them, the only 2 moving being Pleasant View and Brook Park. Oops, I am going way too far here. Let me go back. Sorry. There we go. All right, so this was the result of our first attempt at redistricting. The main goals were to ensure that when we redistricted the appropriate number of students from Pleasant View to Brook Park and Norton, that the boundaries make sense with the new school locations and attempt to follow boundary lines of other levels so that we don't create any new catchments, preferably even reducing the number of catchments. At the time, we had 38 catchments, and we were able to bring them down to 37 with this option, so improved a little bit. The idea here was with Brook Park's new building being to the south of Pleasant View's new building to pull from the rural south of Pleasant View. Most of the population is in the northeastern part of our district. Further southwest you go, the less people there are. We're getting away from Columbus at that point, right? For Norton, we pulled from the part of Pleasant View closest to Norton. And just so you know, this is actually another Tableau dashboard. This was created utilizing the Franklin County shapefile of all the parcels in our district and then seeded with the results from our redistricting efforts. And I think it turned out pretty nice looking. I thought it looked slick. Option 2, with Brook Park also being to the east of Pleasant View, we instead pulled from points east of the new Pleasant View building. For Norton, we pulled from the rural northwest part of Pleasant View. This also would have aided in unifying 2 catchments. But in the end, after community and staff input, we took elements from both options. With regards to moving students from Pleasant View to Brook Park, we decided on all redistricting from option 2, along with 1 neighborhood from option 1, opting to move it to unify it with an adjacent neighborhood. And we utilized both options 1 and 2 for Pleasant View to Norton students. So we even ended up moving a few more students than originally anticipated. Once finalized, this is the map that was officially released to the public. We did end up submitting our redistricting information to our GIS house at the end in order to create this map to release to the public both online and for a giant print at the Board of Education meeting. Board wanted a big map, and I get it. Helps the public see that, right? They all want to see their road. In the final step then, once approved by the Board of Education, I extracted the address IDs from the dashboard and created a SQL script to implement the updates in our Infinite Campus database. We definitely had a happy ending with this project, and the rollout both technically and publicly went very smoothly. Even some very favorable articles from the local newspaper. And boy, if you can win with the press, you're probably doing something right. That's a tough one in our industry. But now we wanted to look to the future and making this project not just a one-off, but a tool to be able to continuously monitor our district boundaries and enrollment numbers. So as we said, our district now has 37 catchments, and this is honestly still too many. Students can be together at one level, apart at the next, split up again. Long term, this number would ideally be much lower. We can do better. In the time since the middle school redistricting, the need has arisen where we want to look at future enrollment numbers for schools to see if there could be trouble ahead with some of the elementary kids coming up into the upper levels. Could a school's enrollment be set up to drop off or increase considerably in the coming years? Or is this just a blip for one grade level in student numbers for that current year? And if I was going to build a dashboard to help identify these trends for the entire district, not just middle schools, then I'm going to need to build this bigger and better dashboard from lessons previously learned, utilizing new updates from Tableau and offering more options to the user to color and filter results, such as municipality, township, previous redistrictings, apartment complexes, and mobile home parks to ensure no splitting. We have this data, let's use it. So here it is, our new and improved dashboard for enrollment planning and, if necessary, redistricting. On the left-hand side of the dashboard, we have the current enrollment numbers for each of our schools, which are color-coded by level, with our elementary schools in red, intermediates in green, middles in blue, and highs in orange. The middle of our dashboard is our workspace map, where we can make the changes, and with those improvements to Tableau, observe the changes as well in that one single map. The top rows are to control the coloring options and different filters. And finally, the right-hand side is where we can monitor the counts of addresses and current students per catchment, as well as the total catchment count at the top as we work to redistrict and attempt to reduce that catchment count. So let's go ahead and see this in action here. So here on the left, we can actually see, I'm going to go ahead and pause this real quick. We can, as we mouse over, we get a graph to see all the students enrolled at Central Crossing High School in the orange here. And then the on this here, you can see by grade level, the ones currently there and the ones who will go there. So the color is actually the redistricted. We haven't done anything yet. Nothing's redistricted. And the gray behind it is the current number. So you can be able to compare those to one another. So as we continue to move up here, let's go on again. There's the gray, so there's the current number. You can mouse over that. There you go. It's a reference. There's another reference line. That's building capacity, just like in the last dashboard. And as we go up to the top here, we have our Southwest Career Academy. We talk about having a career academy, right? Well, that draws students from high school. So those, and they go there all day long. This isn't a half and half thing. So we may want to say, let's move it to 100%. Now we can see all those numbers reduced and all those kids are now counted at the career academy. Maybe you want to count the career academy. Maybe you don't. That's what this option gives you. And we made it a percent because sometimes we do expansion. We may say it's going to expand by 50%. Well, let's see what that looks like if we assume current trends. And there you can see which buildings they're coming from. Again, there's a capacity line on that as well. At the top here, we have our map coloring. So these are all the different ways we can color that map. Right now, it's set to redistricted elementary. Again, we haven't done any redistricting on here yet, but there's many different options. Municipality, townships, we talked about that. Filter by grade level. If you just want to see certain grade levels or only houses with students, you could go by current catchment. You could filter by that if you just want to focus on certain ones. Filter by municipality. It's kind of important to keep the municipalities as together as we can, especially smaller ones. Here's by township and county. I say county too is a little sliver at the bottom from Pickaway County in our district. Apartment complex, mobile home park. We have, I think, around 120 apartment complexes and mobile home parks here. So we could actually just look at specific ones and see where they are. Then we see they've been redistricted in the past at the elementary level or at the middle school level. So that can help us to make sure we don't redistrict people any more than we need to, right? So here we're going to go through that same process we did before. We're going to highlight this same neighborhood. It's a popular neighborhood, and we're going to remove it from Alton Hall Elementary. Now, with all these new options, it does take a little bit longer to do now. It takes about 30 seconds. So we're going to fast forward. Now you can see that change to gray where it's now undistricted. All right, now we're going to do the same thing, and we're going to add it into Prairie Lincoln Elementary School. Again, we're going to fast forward about 30 seconds here, a little too far. And now it changed to red, and now it's part of Prairie Lincoln Elementary. You can mouse over any individual address, get those details on it. Most of the stuff that we saw at the top is included there. That's not an apartment complex, but if it were, it'd have the name on there. Here's where you can see individual sets of redistricts. So you can see we redistricted 71 students from Alton Hall to Prairie Lincoln. You can see all the different ones. So again, intermediate, middle, and high, we'll show those, but we didn't do any redistricting, so it just shows they're all staying put. No one's moving in those. We can also, over here, we can bring up certain school years. So while we could see future school years by mousing over the visiting tooltip, we may want to see a specific school year, right? And now you can see with Alton Hall how these redistricted numbers, remember we took kids out of Alton Hall, they are now less. You can see the gray where that is where we currently are, and the color is where it would be if we were to do this redistrict, which would bring them down. And then we can go to Prairie Lincoln and see just the opposite, where obviously we move kids to Prairie Lincoln, so their numbers show that they're higher. And that capacity is an average right there of per grade level, how many you would have with 5 grade levels. And now we can see if we wanted to, we could filter by who's been redistricted or not at the elementary. And of course, we didn't redistrict the others, so they're all no. Over here, then we have our catchments. So as a mouse over there on the catchment, you can see how many students live in that new catchment. This is redistricted, and of course, the top is our totals. So you may have seen at the bottom, there are a lot of worksheets utilized in this dashboard, 85 in total. Part of why we had to do so many is that each one of these bar graphs is its own worksheet, along with having its own viz and tooltip. So why would we do that? It turns out that when you have 30 sets, each with anywhere from hundreds to over 10,000 members, and you want to utilize multiple filters, that starts to tax Tableau a bit. And especially with all 31 schools being represented in one large set of bar graphs. If we didn't do individual ones. If you set it up that way, Tableau has to re-render the entire worksheet, and that took minutes. But if we split each school to its own worksheet, or each bar is its own worksheet, it only has to re-render that one sheet, or whichever two may be affected, in just about 30 seconds. And something that
Well, Robert, I think we've lost some audio for you. The suspense is, oh, and Robert disappeared. Well, there you go. That's what happens with live. Robert will come back. He hasn't finished his presentation, but we'll pick him up where he comes along. I've spoken with Robert before, and this has happened in the past. Sometimes his internet, the district internet kicked out last time we're in his meeting as well. So I'll tell you what. So there's another part to his presentation that he'll get to, and that will be around how he takes it and uses SQL to expand that. I appreciate it. We've got some questions in here for Robert that he'll answer as well when he comes back. But in the meantime, while we still have Albert here, Robert's
back. I'm back. I'm sorry.
No worries.
I looked up and I said I was offline.
Yeah, your audio went out just about the time when you were talking about individual sheets, and you'd explained why you use individual sheets, so the rendering on Tableau goes a little faster. That's where he started to drop out.
Okay, sorry about that. So let's go ahead and.
Well, we're glad to have you back. Albert
glad to be back after the hiatus here. So let's just go ahead and start off right here. I think that's perfectly fine. Or actually, at the very end here, one thing we talked about the sheets. One thing I did make sure to highlight at the Tableau conference is the concept that it's not a big stretch from school district boundaries to things like sales territory when you're trying to do these future what if we move this scenarios. And like any organization with large databases, we lean heavily on SQL to help make possible all the things in Tableau that you've seen here today. So let's start by talking about the data source setup. And there it is. It's a single table. Sometimes it makes sense to write the SQL to create a single view that gets flattened into a single table in a data warehouse overnight, right? This is one of those times. That's how we were able to get that level of speed out of the dashboard that you just saw. We just really want Tableau to do what it's best at, rendering the dashboard. We've left the heavy lifting to SQL to occur a single time overnight for a fast dashboard and with near real-time data. In these two redistricting dashboards you've seen today, these are the lone examples where we even had to utilize Tableau's functionality of creating a hyper extract. With as much as we're trying to do here, we needed to pull from an extract from the data warehouse to function for even greater speeds. So now for what I think it's honestly the coolest part of these dashboards. So imagine you're now done redistricting your school district in Tableau. You've gone through all the processes and meetings and you're there. You're done. Now what? How do you get all those changes into your student information system? Our results are kind of trapped in the dashboard, right? Once again, like the answer to so many of life's problems, a SQL script would be nice. But how do we get that? We've created a series of Tableau calculations to actually generate the necessary SQL script to load every single school boundary change with a user selected effective date, what day you're going to do that in the future, right, at the top of the dashboard into Infinite Campus. This even includes end dating the old school boundaries. So we'll show just how quick this is. So actually, like we saw, there's two dashboards down here, right? But the one we were playing in, now we have this other one. Here's that effective redistricting data I spoke about while this is rendering. It takes about 30 seconds. Let's just fast forward here. There we go. There's our SQL that it just generated from all those things all those changes we made. Then you're going to go in here, just copy out the text, paste it into Microsoft SQL Server, and execute it. And that's it. You've just redistricted your entire school district with what you've designed in Tableau. It's a new tool in our arsenal, created using Tableau and a bit of SQL. So thank you so much to all of you for coming to the K12 TUG today, sitting through my presentation. I do hope that everyone was able to take away some ideas on how to think a bit differently with Tableau and utilize it not just for data analytics, which we obviously did a lot of today, but also as a tool in your toolbox. We utilize SQL at some level in most of our Tableau projects. It's proven to be very powerful in our efforts for dashboard efficiency. As you saw, we all know about using SQL to produce in Tableau, but Tableau can produce SQL if you do it right? So again, we love to share. Here's my information. We can share dashboard layouts, SQL code, or just about anything else that you've seen today. And I'll be happy to answer any questions.
Yeah, so Robert, you got a couple of questions in the Q&A here. The first one came earlier in your presentation from Joshua. He asks, how does the two-way communication work? But you mentioned there's two-way communication between Infinite Campus and Tableau. He asks,
Sure.
can you write to Infinite Campus from Tableau?
Sort of, but not in the way you're thinking. The way they have this API set up is that Infinite Campus has like ad hoc filters you can use. So there are certain ways in Tableau when you're looking at it through Infinite Campus, you can say, okay, I want to highlight these students, and then I want to kind of send this back to Infinite Campus as an ad hoc. So it does legitimately write back to Infinite Campus as a filter. You wouldn't affect change, like you wouldn't want to do something like, say, what we just did, right? Like right back to the school boundary table. It's meant in a specific circumstance, but there is a two-way communication. Like I said, you can filter in Tableau down to what you want, then bring that back into Campus and run reports against that set of kids you just created in Tableau.
Okay. And Emmanuel asks, for this kind of redistricting, have you explored using tools like ArcGIS?
Yeah. So I love maps. That's why I'm here presenting on this, right? I would love to learn that, but I have so many hours in the day, and no one here is a GIS expert. This is one of those. I'm not a GIS expert, but I did stay at a Holiday Inn Express last night, right? Like I think I would love to do that, and if I ever have time, I would love to learn it better, or even QGIS, the free version of that. But it's something that I've never had the time to learn, so I utilize what I know. And plus, this gives us better analytics. It seems like the worlds are merging a lot, right? Like you have ArcGIS is Esri's getting more into the world of data analytics, but its bread and butter is still mapping. And then Tableau is kind of the reverse, right? It's bread and butter data analytics, but it is getting to a lot in mapping. So this has worked for us, and it's the tool we know and utilize. But maybe someday I'd love to learn GIS.
And Emmanuel puts a smiley face at the end of his, so I think he's an ArcGIS user. We actually used ArcGIS as well in Renton School District, Emmanuel, when we were doing our school district rebounding. And Emmanuel has one more question that he was excited that you are using SQL, but he's asking, have you explored using write back with Python? There's a Tableau extension that can allow you to write the redistrict information into a database table instead of changing the sets.
I have not. I have seen that, but again, time for exploration is limited, and that last piece there actually was one of the easiest parts. The hardest part was getting the original dashboard. That second dashboard, I kind of knocked that out in a few hours. That second one, that was actually pretty easy to do. So because I think it's one of those, if we had a lot of need for it, I would probably explore it more, but it's been very limited in the scenarios where we've needed to produce SQL out of Tableau.
Yes, well, there are a whole bunch of other great comments. You got a lot of kudos, including from Katrina, appreciating the insight of making the view to increase dashboard load times. That's really good. It's like to work smarter, not harder. And you had some fans that were at the conference and watched again, so really liking you. Some really good stuff.
Sorry, there wasn't much new material on that. It's pretty well the same thing, just a little abridged. So
the jokes are the same. Yeah. Gayathrithi asks, is there a way to embed any coding or trigger or flow with Tableau, as I am new and want to know more?
Beyond me.
Dennis,
Unfortunately.
Dennis, this is in the chat if you want to answer. Then Dennis says, some of the spatial stuff may have been easier in a GIS tool, but great to see it done in Tableau. Thanks, Dennis. And Dennis is the co-lead for the Tableau Plus map. So you've got some fans here from K12 TUG. You've got some fans from other stuff, but we now want to make sure that we have enough time for Albert. And but first, we've got another gift card roll.
We sure do.
Okay.
So let me bring up my wheel of names again here. There we go. And we're going to spin away. And our big
How about somebody whose first name starts with an S? Oh, so close.
Gina. Gina's our big winner. Gina, if you're still on here, then if you could shoot me, let's make sure
Gina's present to win, Gina, so you got to share if you're here.
Oh, no. Gina is not on anymore. We are going to spin again.
Sorry, Gina. You're watching this later.
You're watching this afterwards.
Video, you had a chance. Sorry, meetings pulled you away.
So instead, let's look for Alex Fisher. Is Alex still here? Alex Fisher is still here.
Woohoo!
So Alex, shoot me an DM here, along with Mariana, so that way I can get your informations and connect with you guys for those gift cards.
All right. And Robert, if you'll stop sharing, then Albert Vega, rather than Alex Fisher, will take it away. Thanks, Albert.
Thank you very much. Can you hear me?
You bet.
All right, let me share my screen. Can you all see my screen?
Yes, all looking good.
All righty. So thank you, everyone. My name is Albert Vega. I am the Senior Data Analyst here at El Paso Independent School District. I know my time is short here, so I want to jump right in it. I've been an analyst for over 20 years now. I have to say that my favorite part of Tableau or any of the analytics that we do now has become mapping. It's been a big part of what we do here at EPISD, and I'll explain why, and you'll see why here in a second. So what I'll cover here is a little bit about our district, why we use maps, some of our dashboard examples. I can't show you everything, but I'll show you a few examples. And then I'm going to give you a live demonstration of what you can do in Tableau and to answer some questions that your administration may have, or maybe even other departments within your district. So about
Albert,
EPISD, yes.
Albert, I know you got great stuff, so don't feel rushed because this is
Okay.
being recorded. So if people have to drop out, they'll still be able to catch it. We'll want to save time for Q&A at the end as well. Just don't feel rushed.
All right. Thank you. Sounds good. So a little bit about our district. We serve approximately 48,000 students. If you've seen us on here before, you know that number has been higher. We are dropping enrollment. That is a trend here in the El Paso area, and I think nationwide. And you can see we have 78 campuses. In the next 2 years, we will probably be close to 71. We are closing about seven campuses within the next 2 years because of declining enrollment, trying to increase the capacity and close the underutilized schools that we have in the district. To the right here, you'll see here is our district boundary, and right in the middle of our district is a giant mountain. So we have a lot of logistical issues when it comes to transportation, and also we are in an open enrollment district. In other words, every student in our district and even outside of our district can attend any campus. So having school boundaries, it's kind of a moot point, but it is something that we have to have. And so, like Robert, we go through redistricting, but for us, it's just a little bit different just because we are open enrollment. So what does open enrollment look like? This is what it looks like. This is one of our dashboards that we have, and I've selected all the campuses, and you can see that we have students from everywhere going everywhere. Approximately 33% of our students that live within our district attend a campus outside of their boundary. And then approximately 12% of our total enrollment comes from outside of our district. So we have a lot of movement within our district. And so utilizing Tableau to identify that movement and to monitor it has become ideal and has become critical for us throughout the years. So why maps? Like Robert himself, he's done redistricting. We do it often. In the past few years, we have redistricted, we have closed campuses, we have consolidated boundaries. We have to monitor student locations, trends. We have apartment complexes that go up and go down. We have subdivisions that are being built and some that are being closed down as well. So we monitor those areas. We identify any trends or things that need to happen. We make those decisions and we take action. And then similar to Robert, everything that we have to do has to be monitored on a yearly basis, especially with declining enrollment and open enrollment as well. And so what are some of the other things that we use dashboards in Tableau for? We look at the student location trends, transportations, their routes. We can look at attendance trends, so we can plop attendance into our maps, so we can identify hotspots in terms of, where are those really high absence rates. And then we do live attend analysis. And what that is similar to that dashboard that you saw earlier. We look at where students live and where they attend and what are those transfer rates. All of that can be done in Tableau. So here's one of our dashboards. This is one of our Live Attend dashboards, the hybrid version of it. It automatically locates the students where they live and where they're attending. It gives us the transfer rates if we need to. We can see those larger areas where the students are coming from. And then we can utilize this dashboard to inform any administration questions that we have in terms of transferring in or out. We can also look at those individual addresses and identify high areas or density areas throughout the years, because those they tend to increase and decrease over time. We can see if the students or the subdivisions or areas of town that are being built are increasing in enrollment or lowering, just based on putting these student plots in the maps in Tableau. Like I said before, we can identify attendance. This is one of our attendance dashboards. We can identify those high areas, as you can see indicated in the bright or dark red. Those where the hot spots are for attendance rates or high absentee. We can have our alpha team, which is our attendance team. They can go out to those areas, to those campuses, and they can help find ways to increase attendance. We can use it for other reasons other than our local or internal data. We take charter school information. We also put that in here. We identify their location, the number of students that they have attending, because charter schools tend to pull students away from El Paso ISD. So we can see exactly where those locations are, how many students they have, and we can use that as information for our administration as well. Some of our public dashboards that we've had in the past, we had our COVID-19 dashboard, which we used during the pandemic, that was able to identify high areas of infection rates. We've built tools for the public that allow them within Tableau to identify campuses that are within their boundary. So all they have to do is type in their address, and it'll find the closest school, elementary, middle, or high school closest to their address within their zone. It also allows from outside of the district. We've geocoded every address within the district or within the county and brought them into Tableau, so anybody in the county can type in their address and can look up and find the closest El Paso ISD campus near them. Now, after they use that tool and they identify the campus that they find closest to them, they can use our school finder, which you can see that has a map here. They can identify the campus, the programs that are offered, and once they find those programs, that let's say the program that they are looking for isn't offered at a specific campus, well, they can use the map to identify a closer campus to them, or a campus closest to them that will offer whatever programming that they're looking for. Similar to Robert, we've done public dashboards for redistricting. In this dashboard, we have our destination district redesign. This is our school action dashboard. What it does is it shows the current boundary of a campus that we may be closing. And then to the right, it'll show what it'll look like with the new combined boundary together, along with the new location of the campus that they'll be moved to. Also gives us the facility condition, additional information about programming, and so on. If this is not a suitable option, because we are open enrollment, we do give them additional family options down at the bottom, closest to them, that'll allow them to make informed decisions based on where they can send their children. All right, so now that I've covered a couple of our dashboards that we have out there, I want to do a live demonstration which will encompass a lot of the basics in Tableau, but it will be a really cool opportunity for you to play with, for those of you that are not familiar with mapping in Tableau, to play with it and to build a really cool tool that will incorporate almost every function available in Tableau. So what we'll cover is latitude and longitude. Robert covered that a little bit. We'll build some points. We'll utilize buffer, intersect, maybe some lines if we have time, calculate some distances, and we'll even build in a custom background if time permits. So what is latitude and longitude? If you were to take the globe, flatten it on the floor, and use the prime meridian and the equator as the X and Y axis, all it is taking your latitude, which would be your X, and the Y value would be your longitude, and it would plot your point on a map. So that is probably the most basic explanation I can give in terms of what latitude and longitude is, and we'll utilize that here in a few minutes. All right, so what is the most asked question that we have here at the district? Because we are open enrollment, we are always being asked how many students live within a certain boundary but attend a different campus, or how many students live within a certain area, attend campus A or attend campus B, and what are those trends over the years? That the scenarios and the different combinations of that question are infinite, and because we are open enrollment, it's never ending. So today I'm going to utilize that question, and I'm going to help you build a dashboard that can help answer the question. So pretend today that we are being asked by administration to identify a spot on a map, whether it be a campus or a bus route, and we want to know how many students live within a half-mile radius, or how many students live outside of that half-mile radius of that point on a map. So I am going to jump into Tableau. I have a blank workbook here. I'm going to drop a very basic Excel spreadsheet. I'm not going to use a database or anything because I don't want to worry about connection issues. So you can see the data that I brought in. It's just basically address ID, latitude, longitude, the full address, and then the state, city, state, and zip. That's all we're going to work with today. And you can see just based on that basic information, we can do a lot with it. So I'm going to jump into a blank sheet. The first thing we're going to do is we are going to generate points on a map based on every one of those addresses that you saw on that spreadsheet. So I'm going to open up a calculation, and I'm going to create a calculated field that will generate those points. So I'm going to name this point addresses, and the function that we're going to use is called make point. And all it asks for is two numbers, which is going to be our latitude and our longitude. And I'm going to say OK. All we have to do is drop that on the blank sheet. The minute we do, you see here are all of the addresses that we have identified in that spreadsheet. And this is just a cross section of the west side of El Paso. And I'm going to show you what we're going to do with this here in a bit. But notice when I hover over any of those points, when I do with the map in Tableau, it can't distinguish between each of those points. So what we're going to do is we're going to tell Tableau, hey, we want to look at each individual point separately. So to do that, all you have to do is take the address ID or any unique identifier for an address and drop it into detail. The minute you do that, you can see each point highlighted separately. The next thing I want to do is I want to take that address and I want to take the full address and I want to drop it into the tooltip just so I can easily identify the name of the street. Now, before I get started, I don't like the way this looks. It doesn't look like a map. It's very basic. There aren't any streets. What we're going to do is we're going to clean it up a little bit, make it visually appealing for the end user. So if you right click on a map and you go to background layers, I'm going to change the style. And you can see you have a few options here. I'm going to change it to dark. Makes it a little easier on the eyes. And I'm going to change I'm going to add streets and highways. You can see I'd already added my streets in here. The only thing is all of those dots, they are a little bit, they overlap a little bit. They are hard to see. I'm going to change the color and I'm going to change the style. So I'm going to change on the marks card, I'm going to change this to shape. And yep, that made it worse, but I'm going to make it cleaner. I'm going to change it to a solid circle and I'm going to change the size down towards the bottom here. So yes, it is a little bit harder to see, but I'm going to change the color. There, now they light up. I can see all of the individual points on a map, and these aren't student addresses. These are just all addresses in that area, that cross section that we selected. So there isn't any student information tied to this. All right. So, what are some of the tools that we can use within Tableau? Your administrator has asked, I want to know how many students or how many addresses or students or whatever the question is live or are within a certain radius of a point on a map. So Tableau does have this tool here. It's called the radial select tool. If I select that and I click on a map, any point in the map, and I click and drag, you can see I'm able to identify half a mile radius from that point on the map, and it selects those addresses. If I let go, the tooltip tells me how many items were selected. The only thing is, everything else on the map kind of disappears and fades out into the background. The minute I move my mouse, I lose that count. I don't know how many it was, and then I don't really know where that point was that I selected. So what we're going to do is we're going to build a tool that that'll allow you to mark that point, keep the point, and count all of the points on a map, and give you some other style options as well. So what's the first thing you want to do? Well, let's go to Google Maps. And I have this cross section. That cross section that you saw on Tableau is basically everything you see right here on the map. If you didn't know this already, if you right click anywhere on a map on Google Maps, the latitude and longitude are already at the top of that drop down for you. If you click on it, it goes into your clipboard. So I'm going to take that and I'm going to go back to Tableau. I'm going to create a calculated field. I'm going to call this point A. And we're going to do what we did before. We're going to use that function called make point, but this time I'm going to paste the latitude and longitude in there. And this is recorded, so you can always come back and mimic what we're doing here. And I'm going to hit OK. I'm going to, I'm going to go back to Google Maps. And I'm going to grab another point just for later. I'm going to grab point right here. And I'm going to call this one point B. There we go. Hit OK. I'm going to take point A and I'm going to drag it onto the marks layer of the map that we've already created. Yeah, it doesn't look like it did anything, but that point is right here. It's really small. It's hard to see. So we're going to update that. We're going to make it more visible. So I'm going to, like we did before, I'm going to change the style of the mark to a shape. And I'm going to go to my custom shapes, and I've created some custom shapes. You can use any shapes you want, but I have some map markers here. Yes, you still can't see it, but now I'm going to change the size. There it is. You can see here's my point. The point that I just created is point A, and I labeled it as such. So now we can see that point A is right there on the map. Now what we want to do is, the question was how many addresses are within a half mile of that area. So what do we want to do to do that? Well, I'm going to use a function called buffer, and I'll call this calculate. I'm going to open a calculation here, and I'm going to create a calculated field called buffer A, and the function is called buffer. And the geometry, what the geometry is the point that we created. So point A, I'm going to use that. And then it's going to say the number. So in other words, what is the radius? It's going to create a radius around that point. So we wanted to use a half mile. So I'm going to put 0.5. And then the units are miles. That was the question. We're going to give them that answer. So there we go. I've created buffer A. Now I'm going to take that buffer. I'm going to drop it onto the marks layer again. Watch what happens. It created a radius right around that point A that's exactly half a mile. The only thing is it hides the points, and it's a little difficult to see what's back there, and it actually hides the point A that we put on the map. So I'm going to click and I'm going to drag the point A buffer that we created down to the very bottom. So it makes it a little easier to see, right? But this time, for your end users, I'm going to make this much easier to see. So I'm going to disable that selection. If you hit this drop down where the title is, you can hit disable selection. Let me show you why. If I'm hovering over any of these points, you can see that the address pops up. But once I get into the buffer zone, it disappears. Okay, I can't see what those addresses are. And if you ever need to identify what those are, you can't do that with the selection enabled. So I'm going to disable the selection, and I'm going to do the same thing for the point. Okay, so now when I come over here, the points are enabled. I can see them. But I'm going to take it a step further. I'm going to go to color, and I'm going to disable the color completely. But I'm going to turn on a border. And there's a reason why. I don't want the color in the background to interfere with what we're about to develop in this dashboard. So yes, we see the circle, but we don't see anything highlighted, or we don't see what addresses are in here within the buffer. We're going to fix that. So I'm going to create another calculation, all having to do with mapping, if you haven't noticed. This is going to be, I'm going to use the function called intersects. And I'm going to call this did I spell it wrong? Sex, A, and intersects. There it is. It's going to ask for two things. It's going to ask for two geometry points. And so we have two geometry points that we want to use. We want to use the buffer that we created, which is basically that radius around point A. And then we want to use the addresses, all the points that we created as well for each address. So now what it's going to do, it's going to give me a true false value for every point that intersects with that buffer. So what am I going to do with that? Well, let's click on, in the marks card, I'm going to click on the point addresses. I'm going to take that intersects and I'm going to drop it on color. Watch what happens. Now, every address within that buffer zone has been highlighted with a different color. It's really cool, but right now, all we know is that they're colored. We don't know how many there are. So to help answer that question, I'm going to open up a new sheet, and I'm going to create a calculated field. This isn't going to use any mapping, but this is going to use a function everybody's familiar with, and it's going to use the count function. I'm going to just call it count A, and I'm going to count distinct, and I'm going to put an equation in here that says if the intersects is true, then count the address ID. All right, so what does that do for me? I'm going to hit apply and OK. I'm going to drop that onto my text icon there. And now you can see, based on the map that we've shown, we know that there are 1,150 addresses selected within that with that buffer zone that we've created. I want to make this a little bit easier for your end users. So we're going to say addresses within 0.5 miles of zone A, or point A. All right, let's make it a little bit bigger because we're going to give this to our end users to see. I'm going to make it 12. And you know what? Let's make these numbers, let's make them stand out a little bit. All right. Very cool. All right, so what do we have? Now we have a text field that shows, or a sheet that shows us how many addresses were selected within that buffer zone within a half mile of point A. I'm going to come over here. And you know what? Let's add this to a dashboard. I'm going to take sheet 1, drop it in, and I'm going to take sheet 2, and I'm going to float it over the top here. And it doesn't look very good, so we're going to fix that. We're going to take the title off, and we are going to fit it to the entire view. There we go. So as we know, working with school districts, it's not always a definite, half mile, or it isn't a definite within a certain amount of distance from that. We want, they're going to want to vary that. So they're going to say, oh, you know what if it was a mile, or what if it was a mile and a half, or what if it was 0.6 of a mile, so something like that. So let's make this dynamic. Okay, I'm going to make it dynamic. I'm going to go back into the map. And what we're going to do is we're going to create a parameter. And this parameter, we're going to call it buffer param. And I'm going to leave it as float. And but this time I'm going to change it to range. And I'm going to select all 3 of these here, minimum, maximum, and step size. So for the minimum, I want to say 0, because we're going to make that buffer zone variable where the user can change it on their own. The maximum, this is a small map, and I'm not going to go over 3 miles since we're using miles. And the step size, I'm going to use 1/10 of a mile. And what was our original value was 1/2 mile. I'm going to leave it at that. I hit OK. Now I have a parameter that we can change. So I'm going to show the parameter so you can see. And it is a variable parameter that allows me to adjust the value by using the slider here. Well, let's take that value. Let's go back to our buffer that we created. And I'm going to delete that 0.5 that we added into the calculation. And I'm going to drag and drop that new parameter in there. And I'm going to hit OK. So now watch what happens when I start using the slider. Now you start to see some changes, right? So everything is highlighted based, and it's a little bit more dynamic. So let's go back to our dashboard, and I'm going to show that parameter. There it is. Now, as we move the parameter, you can see on the dashboard, it changes along with the values that we had here. So your end user can sit there and they can adjust the values as they want, as they wish. And then they can see the value change or the number of addresses within that zone. The only thing is, if you notice here, that number didn't change. The 1/2 mile that we put in the original text, I'm going to take that out and I'm going to make it variable by dropping the parameter into text. And I am going to replace the 0.5 with the buffer parameter we just created. Let's delete this guy. All right, let's make this one bold so it stands out a little bit. Hit OK. All right. So now what we can see is the user can come in here, change the value, and then the value appears both the distance from point A and the overall number of addresses. Really cool. All right. So, and we can adjust the format of those numbers. You don't have to have that many decimal points, but what we can do now is, remember I created a point B. Let's go get that point B. I'm going to drop it into the dashboard. I know you can't see it, so I'm going to do the same thing we did with the last one. We'll change it to a shape. Go in here and change the shape that we've to a shape that we've predefined. I'm going to change it to point B. Change the size. There we go. Now you can see point B in here. And you know what? Let's disable the selection like we did in the last one so we can see those points. All right, that looks cool. But now what I want to do is I want to add a buffer around point B. So I'm going to zip through that really quick. So let's name this buffer B. And we put point B in there, the units, and I'm going to use that buffer parameter that we created and indicate the units, which is going to be miles. There we go. Take the buffer, I'm going to drop it onto the marks layer, and now there's your new buffer for point B. Let's do the same thing we did for the last one. I'm going to drop the buffer down to the bottom. I'm going to hide the color, add a new border here. But the only thing is we need to add the intersects. So let's find all those addresses that intersect with B and intersects. And then we want to know the buffer for B and all the addresses that we've created here. There we go. There it is. Now I'm going to go back to my point addresses and I'm going to drop the B intersects B, the true false value on color. They highlighted, but look what happened. Everything that we selected in point A is gone in the buffer zone for A. So there's a trick. If you click on these, on the two, if you hold your control key and you select both intersects value and you right click and you create a combined field, notice it creates a combined field based on A and B. I'm going to take that, drop it on the color. Now look what happens. Now those both areas are colored. But you know what? I don't like the colors. I have a predefined color palette here that I've developed just for this to make them stand out a little bit. I'm going to assign the palette. There we go. Now you can see all of those areas highlighted that have been within that zone. And you can see that it's dynamic as well. And all of those areas are selected as soon as we move the buffer parameter. I'm going to go to the dashboard again. And notice up here, we're only counting point A. Well, we need to update that. But notice when I make my zone too big, notice that area in between here. I don't know if you could see that or not, but if let me make it a little bit bigger. Notice when they overlap, it changes color as well. So let's say, based on this information that you provided to your administrators that say, hey, so many addresses fall within each of these buffer zones within each point, they also want to know how many addresses are within the overlap here and how many addresses fall outside of these zones. Let's count those and let's put them in the dashboard for them. So that way they don't have to do any additional work. So all we have to do is first count B. We're going to count all those in zone B. And then let's say if intersects B equals true, then address ID. All right, there we go. So we've counted the first one. I'm going to drop that in here. Now you'll see how many addresses show up in that second point within that second zone. Now we want to count all of those that are overlapping in the zones. So how do we do that? So let's count overlap. It will follow the same process. We're going to count those that intersect. Oh, let's do if intersects A equals true and intersects B. And because they're true and false values, you don't have to put equals true. You can just leave them that way if you wanted to. But just for reference, I'm going to throw them in here so you can see. Intersects A equals true and intersects B equals true. Then let's show that address ID. Let's count it. All right. That's the overlap. Now we want to count the ones on the outside. How do we do that? It's exactly the opposite of the one we just created. We're going to add the same intersects calculation, but we want to know if they equal false. It'll give us all of those that fall outside of the zones. Whoops, not false. All right, very cool. Let's drop both of those in there. Let's drop an overlap first, and we'll drop the outside in second. Now let's go in here and format these so we can see them a little bit better. Let's add this guy. Now formatting we can always do later, but I think just to show you examples of how this works, this is a really good start. And then we have outside both zones. All right, so let's go back to the dashboard. Let's check it out and see if it works. All right, it's kind of ugly, but it's doing the job. Now, as we click through here, you can see every one of those numbers is changing. Everything is working as intended. The only thing is, the number of decimal points, that's the only thing you would have to worry about. You want to go in there and you want to reformat all of that so it's a little bit cleaner for the end user. I don't think they need to see that many decimal points. You format it to make it look nicer. I've developed using the same data set. I want to show you what I created here. You can take it a step further. Now I know this is a point A and B that you went and selected off of Google Maps, but as we know, those can change as well. Let's say that these points that we selected on the map aren't going to suit the end user very well. We also can take the information and we can make it dynamic as well. And I'll show you that here in a second while that opens and loads. First, since I have a little bit of time, I'm going to show you the end user wants to know how many miles is it between point A and point B. But first, before we do that, let's create a line to make it look visually appealing. So there's a function in here that you can use called make line. And it's going to ask you for a start and end. And you're going to take the two geometry points that you created. So point A and point B. I'm going to take that function that we just created, the calculated field. I'm going to drop it on the marks card. And you can see it created a line here. Change the color to make it a little more visible. Now you can see that line right between A and B. Now you want to know the distance. The end users are going to want to know the distance between those two lines. So let's just call it distance. And there's a function in here called distance that you can use. It's going to say start and end. You're going to use the same 2 points. You use point A and point B. It's also asking for the units. And in this case, we're using miles. I'm going to take that value and I'm going to drop it on the label for line. But look what happens. 19,000 doesn't sound right, right? And it's because it's using the sum of the value for every address. So what we want to do is we want to change that to max. And I'm going to come back in here and I'm going to change it so we can see it on the map. I'm going to add a few line breaks there, change the color, maybe the size, and let's just make it bold. All right, let's go back to the map. There it is. Now you can see the distance between is 1.9 miles. Let's make it a little easier to see there. Now it's a little more self-explanatory. There we go. So now we have the distance between 2 points. We're able to calculate how many addresses are within the 2 zones. We're able to calculate how many addresses are overlapping and how many are outside of those zones. So let's say you're doing this for your transportation department. They want to know how many addresses are outside the 2-mile radius of a specific campus. Well, this is one of the tools you can build for them. All you have to do is place in the lat long for the campus and then bring in all the addresses. The other tool that I had made using the same data set, I threw it into our template and I made it dynamic. So I brought in 3 points, and you can see here I can adjust the slider like we were doing before. The only difference is for point A, B, and C, I made them to within a parameter to make it dynamic. So point B is a little bit too far away. Let's go back to Google Maps, and I'm going to grab a point a little bit closer. And I just selected the lat long. We'll go to point B. I'm going to delete that, enter in the new point, and you can see the entire thing changed. So you can make it dynamic for your users. You can do a lot with a tool like this, and keep in mind, all we used in this example is just the addresses. That's it. And we use the functionality of Tableau to build a tool that analyzes it in a bunch of different ways by counting points, calculating distance, looking at how many addresses overlap. We're able to do quite a bit here with just imagine what you can do if you brought in attendance or you brought in different information from your SIS and you wanted to analyze the data based on student location or testing or whatever you're looking for. You can do that all within Tableau. The sky's the limit here. And so as you can see, it's a really cool tool. There are a lot of things that you can do in Tableau with mapping. It's become our favorite go-to piece when it comes to rezoning for the district. And I think with that, I can open it up for questions.
Yeah, thank you, Albert. So much covered in live. It was terrific. I was sharing in the chat that you guys create your own templates that you have as the background there in your dashboards. So you really look at that well, but showing all the buffers and the distance and all the calculations, that's really helpful. And I'm sure people are either furiously taking notes or waiting to watch again on the video, which will be up later today. You do have a questions in the Q&A. Let me get to that question in the Q&A there.
Okay.
And the question is about your 2 questions. One is from Wendy, who asks, what do you use to geocode all the addresses in the county? Is it secure? Is it free?
So that's a good question. So a lot of the your state and city, county, they all have free, or they should have a website where you can go out and download. We're lucky here in El Paso, we can go out and download all of those plots, and they're geocoded for us. But for those different areas that aren't, we use a tool called Alteryx to geocode. And in terms of student addresses, we can pull all of those geocoded addresses out of the SIS if we need to. If they don't have a geocode for whatever reason, we're able to geocode them ourselves. We use a tool that it's not free, of course, but there are free options out there if you do need to geocode a specific address or a single address, Google Maps is a great tool to use. There are other free tools out there that you can use out there, like the Census Bureau has a free geocoding option, but it's limited because it's delayed. It doesn't have new subdivisions out there, but it is something you can use. But yeah, we do have our own tool that we geocode everything.
And Andrew asked very similar questions. Where did you obtain a data set like this to map all the addresses in your area? I think you said the county is a good place to go. In Renton School District, we're in King County, Washington. We use the King County tax parcel data set as well. And that's something they want to do for their district. I don't know if you looked at the chat, but they're blowing it up with kudos and thank you. And what a great opportunity that we had to watch you do it live. We have gone over our times. We want to respect your time because those who are still around are probably on their summer break. So we're glad that you're here, or staying up late to watch it all. But we're going to end quickly here. I want to just make sure that you know that there are more events coming up, and they're coming up in September. We're taking a summer pause, and we'll be back with the K12 TUG for you. In the meantime, this summer, you can do some summer viewing, watching old ones on the Data Fam channel on YouTube. And we want to thank also our sponsor, Plant Moran, Stephanie works for. They do all sorts of great services and training for them. And if you're interested, reach out to learn more about how they can help you, be your guide on the side as you go through Tableau. Reach out to us. We want to thank you. If you still have questions, that's around. But right now, we're just going to end our recording of this, and we'll see you in the fall.